Hello everyone. Today I'd like to introduce you the concept of determinants. Determinants are an important mathematical tool that can help us solve a system of linear equations and analyze matrices. Determinants can be useful in various mathematical applications, such as finding the inverse of a matrix, computing the area and the volume, and solving systems of linear equations. Let's get started. If A is a square matrix of order 2 by 2, where A equals A, B, C, and D, then the determinant of the matrix A is denoted by the symbol. Here it's the determinant A, this symbol, like the absolute value. And it's called the determinant. It's called determinant of the second order. And it's the number, its value defined as the follows. Multiply A by D, and A and D, they are called the principal diagonal. Multiply A by D minus the product of B times C, the product of B and C. So what is the value of the determinant? It's the product of the principal diagonal, A times D minus B times C. So I want to get the value of this determinant, 3, 4, 7, 8. So multiply 3 times 8, the main diagonal, 3 times 8 minus 7 times 4. That is the value of the determinant. 3 times 8 is 24 minus 28 equals negative 4. How can we find the value of the following determinant? Multiply the main diagonal, sine times sine, it's sine squared theta, minus the product of the other two elements, minus negative cosine squared theta. Negative after negative, it's positive, so it will be sine squared theta plus cosine squared theta equals 1. Proves that the determinant 2x minus 1, 2, and 3x plus the determinant 3, 6x, x1 equal this determinant. So find the value of the first determinant, 2x multiplied by 3x, so it's 6x squared, minus the product of the other two elements, minus 2 times negative 1, it's negative 2. Okay, plus 3 times 1, 3, minus 6x times x, 6x squared. So it will be 6x to the power of 2 plus 2 plus 3 minus 6x to the power of 2. We have 6x to the power of 2 minus 6x to the power of 2. Then 2 plus 3 equals 5. The right hand side. 3 times negative 7 minus 13 times negative 2. 3 times negative 7, it's negative 21 minus 13 times 2, 26 will be plus 26 equals 5. So the left hand side is equal to the right hand side. How can we expand the third order determinant? We need to know the sign of the determinant in expanding. Here, plus, negative, positive, negative, positive, negative, positive, negative, positive. What does it mean? In expanding the determinant, we must know that the first element, which is written in the first column and the first row, is positive. And this one is positive, and here it's positive, positive, positive. And the other elements, we will write negative before it. So how can we do it simply? I want to expand this determinant. We can expand the determinant using any row or any column. We can use any row or use any column, as you like. So if I decided to take the first row, and someone else decided to take the second row, both of them, we will get the same result. Okay, so here, if I'm going to take the first row, look at the sign well here, plus, minus, plus. Here's the sign. And then write 2 multiplied by the determinant of the second order. Hide the row and hide the column, which 2 lies in. So we're going to hide the row and hide the column. Row and column. Then you are left with a determinant of a second order, 0, 4, 1, -3. And the sign of 3, it's negative. Write negative before writing the second element. So it's -3 multiplied by. Cancel or hide the row and the column of 3. Cancel the row and the column of 3. So let's cancel the row and the column of 3. Then you will get a determinant of second order, -2, 4, 1, and -3. Then plus, write a plus, then write this number with its sign, it's -1. Then hide the row and the column of -1. Let's hide the row and the column of -1. Then you are left with a determinant of second order. It's -2, 0, 1, and 1. So it will be 2 multiplied by, find the value of this determinant as we used to find. It's 0 times -3. 0 multiplied by -3 minus 4 times 1. Minus 3 multiplied by -2 times -3 minus 4 times 1. Minus 1 multiplied by -1 times 1 minus 1 times 0. So here it's 2 multiplied by -4. And here it's -3 multiplied by 6 minus 4, it's 2. And here it's -1 multiplied by -2 times 1, it's -1 minus 0. So it's -2. 2 times -4, it's -8. And here it's -6. And here it's a plus 2. So -8 here minus 6, -14. -14 plus 2, it's -12. That's it. I want to get the value of this determinant so we can take any row or take any column. In this one, we can take any row or any column, but I want to take the second row. Okay, just it's a kind of a change. Then take -2 multiplied by the determinant of second order. Cancel the row and the column of -2. Then you are left with 4 numbers, 0, -5, -3, and 6. And what is the sign? What is the sign of the second row? It's negative. And this negative is different from this negative. And here it's a positive. And here it's negative. That is the sign of the row. So we wrote negative here. Before -2, because the sign here is negative, or we must put negative before this element. So here it's negative. The sign is negative. Then write -2, hide the row, hide the column, and write all elements. There is 0, -5, -3, and 6. And then write a plus 4 multiplied by, cancel the row and the column of 4. So here it's the row of 4 and here it's the column. Then you are left with 3, -5, 7, and 6. Okay, then write -1 multiplied by, cancel the row and the column of 1, and it's not -1, it's 1, but we have negative before 1. Cancel the row and the column, so you are left with 3, 0, 7, and -3. 3, 0, 7, and -3. Then negative times -2, it's 2, multiplied by 0 times 6 is 0, minus -3 times -5, it's 15, minus 15, plus 4 multiplied by 3 times 6, it's 18, minus 7 times 5 is 35, minus 1 multiplied by 3 times -3, minus 7 times 0. So here, it's a 2 multiplied by 0, minus 15, it's minus 15, so it's minus 30 here, plus 4 multiplied by 18 plus 35, and here it's minus 1 multiplied by 3 times -3, minus 9, and -7 times 0, it's 0. So it's -30 plus 4 times 18 and 35, 18 and 35, 8 plus 5, 13, carry up 1, 1 plus 1, 2 plus 3, 5, so it's 53. 4 times 53, and -1 times -9, it's a plus 9. So it's -30 plus 4 times 3, 12, carry up 1, 4 times 5, 20 plus 1, it's a 21, then plus 9. So it's -30, and here we have plus 212 plus 9. When adding them, it will be 230, and here it's 1, 9 plus 2, 11, 1 carry up 1, 221 minus 30, it's 1, and 12 minus 3, 9, so it's 191. That's it. If the value of the determinant equals 0, find the value of x. As I said before, we can take any row or any column, but in this case, we can take the first row. Now, determine the sign firstly before finding the value. It's here plus, and here minus, and here plus. We'll write this sign. So here plus 0, and 0 multiplied by anything, it's 0. So don't care about 0, write -3. -3 multiplied by, cancel the row and the column of -3. It's not -3, but this negative is the sign of this element here. So cancel the row and the column, you are left with, here it's x, 0, 1, and 3. And then write plus x and cancel the row and the column of x. So we're going to cancel here this column. You are left with x1. Here it's x, and here it's 1, and here is 1, and here is x plus 3 equals 0. Then x times 3, 3x minus 0. 1 times 0 is 0, so it's 3x. And -3 multiplied by 3x, it's -9x. Plus, here it's x multiplied by, find the value of the determinant, it's x times x plus 3, so it's x squared plus 3x. And 1 times 1 minus 1 equals 0. So it's -9x plus x times x to the power of 2, it's x to the power of 3. X multiplied by 3x, it's 3x to the power of 2. And here x times -1, it's -x equals 0. Then we can take, rearrange them and take x as a factor. So here it's x to the power of 3 plus 3x to the power of 2. And here minus 9x and minus x, it's minus 10x equals 0. Take x as a factor, then you are left with x squared plus 3x minus 10 equals 0. Then factorize two numbers, their product -10 and their sum 3, 7 and 5. and 2, 5 and negative 2. So here it's x and x, 5 plus 5, and here it's negative 2 equals 0. So I have three solutions for x equals 0, x plus 5 equals 0, for that x equals negative 5, and x minus 2 equals 0, and from that x equals 2. That's it. If A is a matrix of order 2 by 2 and the determinant of A is 7. What is A? I don't know, but I know that the determinant of A is 7. And pay attention that the order is 2 by 2. So it's n by n. And this matrix is a square matrix, 2 by 2. How can we find the value of the determinant of 3A? You know here, because we have a matrix of order 2 by 2. So take this number here directly. This is a rule. We can deduce it later. Take this 3 here and raise it to this power, to the order of the matrix, so n. So it's 3 to the power of 2. 3 to the power of 2 multiplied by the determinant of A. So it's 9 multiplied by 7 equals 63. And if A is a matrix of order 2 by 2, and the determinant of A is 10, find the determinant of 4A. So here you will take this 4, you write this 4 raised to the power of n, raised to the power of 2. It might be 2, it might be 3. It might be 4 because I'm talking about a square matrix of order 2 by 2 now. So it's 4 to the power of 2 multiplied by the determinant of A, which is 10. So it's 16 times 10. It will be 160. Find using determinants the area of the triangle XYZ. X is 1 and 2, Y 3 and 4, the order pair 3 and negative 4, and Z negative 2 and 3 by using the determinant. So it's a rule we apply. What is the rule? It's half multiplied by the determinant. A determinant of order 3 by 3, and here X is 1 and 2. We write here 1 and 2. Y is 3 and negative 4. Write them in order. 3 and negative 4. Z is negative 2 and 3. Right here, negative 2 and 3. So I wrote all X coordinates here and all Y coordinates here. What about the third column? The third column is constant. Right, 1, 1, 1. Okay, so what I did again, I wrote here all X coordinates and here all Y coordinates in the 3 vertices. And here 1, 1, 1. In any triangle, write 1, 1, 1. So to find the area it's half multiplied by. We can take the last column, okay? And before finding the value, just write the sign of each number here. Here it's a plus, here it's a minus, and here it's a plus. So it's 1. I don't care about writing 1, so cancel the row and cancel the column. So here it's the row, and here it's the column. So it's 1 multiplied by 3, negative 4, 2, 3. 1 multiplied by 3, negative 4, negative 2, and 3. And negative 1 multiplied by negative 1 multiplied by. Here, cancel the row and the column. So right here, negative 1 multiplied by 1, 2, negative 2, and 3. And lastly, we have here 1, right, plus 1, its sign is plus. And we'll write cancel the row and the column. So it's 1, 2, 3, and negative 4. 1, 2, 3, and negative 4. So it's half multiplied by 3 times 3, 9. 9 minus 8. So it's 9 plus 8, it's 17. And here it's minus 1. 1 times 3, 3. 3 minus negative 4. 3 plus 4, 7. So it's minus 7. And here negative 4. Negative 4 minus 6. Negative 4 minus 6. It's negative 10. Then it's half 17 minus 7. 10. And 10 minus 10 equals, I think I made a mistake. Here it's 9, 9, and here it's minus 8. So here it's 1. So it's 1 minus 7 minus 10. Sorry for that. 1 minus 7 minus 6 minus 6 minus 10. So it's minus 8. Minus 16. Half times negative 16. It's negative 8. Then take the absolute value of negative 8 because there is no area in negatives. So absolute value of negative 8, it's 8. So 8 is square units. That is the area of the triangle. I want to prove that using determinants that the points negative 2, 4, 3, 0, 8, and negative 4 are collinear. So we deal with them as a triangle. So we'll find the area of this triangle. So I'm assuming that there is a triangle passing through the 3 points here. If the area of this triangle is equal to 0, so the 3 points in this case are going to be collinear. So we'll find the half and write all x coordinates here for the 3 points, negative 2, 3, and 8. Here write 4, 0, and negative 4. The first point again, negative 2 and 4. Here, negative 2 and 4. Here is 3 and 0, and here is 3 and 0. And here is 8 and negative 4. Here is 8 and negative 4. The right 1, 1, 1. And find the area. You'll find at the end that the area is equal to 0. So that means the 3 points or the area of this triangle is 0. That means there is no triangle, but the 3 points don't make a triangle. They are collinear. So the area is equal to 0. Solve the system of the following equations using Cramer's rule. And the Cramer's rule depends on the determinants. So look at the steps we follow to find the value of x and y. They are two simultaneous equations. So write delta. What is delta? Is the determinant of the coefficients. So it's 6, and here 3, negative 5, and 3. What I did, I wrote here x, all x's, and here all y's. And the value of this determinant is going to be 18. 6 times 3, 18, minus 3 times negative 5, so it's 18, plus 15, it's 33. That is the value of this determinant. So write delta x. So what is delta x? The determinant, but hide x, or don't take x, and write instead of x, in this case, write the absolute values here. It's negative 23. You write them instead of x, negative 23. So the term delta x, don't take x. Delta x means don't take x. I write y as it in its place, 5 and 3. Then it's negative 23 multiplied by 3 minus 16 times 5. Negative 23 multiplied by 3, it's negative, and here it's 9, negative 69. And here 5 times 6, 30, 0 per up 3. 5 times 3, 5 plus 3, 8. So it will be negative 69, okay? And here it's negative. Here it's negative 5, sorry for that. Here it's negative 5, so it will be plus 80. So it will be 11. Negative 69 plus, it will be 11. Then you will find delta y. What is delta y? Delta y means don't take y. So if I didn't take y, what would I write instead of y? Don't take y and write x as it. It's 6 and 3. Then change all coefficients of y. And write instead of them absolute values. Absolute values. Here it's negative 23 and here it's 16. So delta y, it will be 165. 6 times 16 minus 3 times negative 23. It will be 165. So once again, what I did, we have three main steps here. The first step, delta. Delta is the determinant of the coefficients. The determinant of the coefficients. Delta x, don't take x and write instead absolute values. Delta x, don't take x and write instead of that absolute values. Delta y, don't take y and write instead of y absolute values. Then what is x? X equals delta x over delta. And what is y? Delta y is delta y over delta. So delta x over delta. Delta x here, it's 11 over delta. 33, 11 over 33 is 1 over 3. And y is delta y over delta. Delta y, here it's 165 over 33 will be 5. So what is the solution set? In this case, the solution set is going to be x and y, 1 over 3 and 5. I hope you enjoyed this session. See you in the coming episodes. Goodbye.